All right. I know that you have already, where you're supposed to already go through this motion graph check-in before you watch the video. And hopefully, as you were doing that, if you needed to reference this, that's fine. I'm hoping that you can do this without referencing back to the motion graph sheet that we have in our notebooks or in our folders, wherever you tend to keep yours. So we'll go here to question number one. This is a position time graph. So I'm doing the first thing I'm supposed to do, position time graph. And what we have to find out is how much longer did the bus remain at the second stop as compared to the first stop. So I am looking for a place where this bus stopped. Now, if I reference back to, oops, wrong thing there. If I reference back to my motion graph on distance time, position time graphs, this horizontal line means at rest. So I go back and I'm thinking, okay, here is a stop. Whoa, that's terrible. Here's one stop. Here's the second stop. Okay, and I can tell that each one of these little ticks, 1, 2, 3, 4, 5 minutes. So each tick is a minute. So this first stop was 1, 2, 3, 4. This second stop is 1, 2, 3, 4, 5, 6, 7. How much longer did he stay at the second stop? I think that one is fairly easy, and we will continue to move on. Now, as we move into number 2, this is showing the motion of a student. I'm going to do what I'm supposed to do. This is a distance time graph. So I know that these motions are going to mean different things on this graph than it would have on a speed time graph. How long did he walk when he started walking the second time? Okay, so I see the first walk. I see him take a break. Now I'm going to see a second walk. Now we start that second walk, if you agree with me, at 6 minutes. And it stops, our graph stops here. He's walking at a pretty fast rate, and then he kind of slows down a little bit. It's not as steep. So from 6 to 12 would be, I'm sorry, it's not minutes, seconds, 6 seconds. So here's the first walk. There's a pause. Here's this part here, this whole thing is the second portion of my walk. That takes from 6 to 12. And if you add that up in seconds, don't be like me and do it in minutes, that would be 6 seconds. 6 seconds. This has always been one of the tougher graphs that I go over during the year, mainly because we're not used to seeing all of this stuff in here. All of this stuff in here. And I understand that. But I think if you think about it as if they were just points there, then it kind of starts to make sense a little bit more. They just happen to put the picture of the helicopter. So I'm going to do my thing here. I'm going to find out what kind of graph it is. I have a position time graph. That's the same thing as a distance time graph. So now I understand what each of these motions means. During what time period did the helicopter's position change the least? Now there's that word again. We've had increase and decrease that we've struggled with. We've struggled a bit with least. This means like the less amount. When did it change the less amount? So you have to look at how far it moves during each time. So A says between 1 and 2 minutes. Okay, so if I look at minute 1, he is at 200. If I look at minute 2, he is at 600, and we know that 200 to 600, this is going to be a change of 400. Yes, I'm writing with my mouse, so it's, or my trackpad, it's terrible. All right, let's look at 3 to 4. That is, good gracious, like 800 to 790. So that's like 10. That's not a huge change at all. He barely, I mean, he maybe moved down a little bit. Let's look at 5 to 6. So from 5 to 6, he went from 500 to 0. So that's 500. We know it's not going to be C. And then I can barely see that it says 7 to 8 minutes. You have it in front of you. So from 7, he went from 300 to 700. That is also 400, which is equal to what A was. So it's not A, it's not D, but it is B. Can you, I'm hoping, I kind of wish we would do this in class, and we'll probably do some of these again on Monday to review, but I can see that from right here, he moved from 1 minute to 2 minutes, because that's the minutes. He moved from 200 to 600. That's a movement of 400. So between these two lines, he only went from like 800 to 790. That's only 10 meters of movement. That's not a lot of movement at all. Very tough question. Typically when I've put this on the tests, lots and lots of kids have missed it. So I left it off this time, trying to make us be a little bit more successful as we were working on the test. But we're going to definitely go over some of these struggle graphs on Monday. All right, I'm going to find out what kind of graph it is. It is a position time graph. We also know that means a distance time graph. And if I look at this, I have the circle, which is this one, is student X. I have the diamond shape, which is student Y. And I have to find out what happens. Student X starts out slower. So here is student X. And student X starts out slower than student Y. But student X finishes the race first. So let's see. Let's follow this along. It does look like student X got to the end of the race faster. I'm kind of liking that because listen, the line over here is steeper, so student Y is faster at the beginning, and student X finishes the race. Let's try this out. Student Y starts out faster than student X. So let's do this in a different color. Student Y starts out faster. Let's see here. Student Y absolutely starts out faster. And student Y finishes the race first. Well, we saw that that is not true. Okay. This next one says that student X starts out faster. So I have this would be the student X line. And we know that this line over here is steeper. So this one is not true. And then this one is student X starting faster and student Y starting slower is the same statement. So did student Y start slower? No, because he started out at a steeper line closer to the Y-axis. So this one's actually incorrect as well. And I always hate it. This is me. I don't know about you, but I hate it when A is the right answer because I'm always like, there's no way they'll make A the answer. So I always try to talk myself out of it, but don't. If you can talk yourself through the graph, you know you have the answer correct. Don't be afraid to answer that. Here we go. This is one that I like. I like to see this. Like it's nothing, no craziness, no switching around of things. And I know that if I look back here, this is just your simple comparing graphs. We know that it's not always the dotted line. It's the steeper line. I know somebody thought it was the dotted line. It's the steeper line that's fastest. They just sometimes this dotted line is the steeper line. So let's look at this. We know this is, I mean, seriously, look at how similar this graph and this graph is. Very similar. We know that Carlos is the steeper line and Carlos won the race. A says both boys finished the finish line at the same time. Now, I know you're looking at this finish line saying they're touching it, but look at how much time it took. So they did not reach it at the same time. Andrew won the race. Andrew is way over here. Some misconceptions are that this line is longer, meaning that he is faster. That is incorrect. It's the steeper line. So we know that Andrew did not win the race. Carlos won the race, which is what I thought initially because it's just like this graph. So I like this one, but I'm going to check D just in case. Andrew won the race is not correct. Therefore, C is the best answer, and I'm going to move on to the next one. Sometimes when we have graphs like this, distance time graph, they kind of give it to you. They tell you that it's constant speed. So they're going to ask you a question about the graph. What can be predicted if this car travels 2 hours? Well, I can see this is where it gets tough. This is in minutes. 60 minutes is equal to 1 hour. At 60 minutes, he had gone 60 miles. So then I could actually draw, if I needed to, oh my goodness, that is the worst triangle ever. Trackpad is not working today. If I draw my DST triangle, and I have, wow, this is atrocious, 60 miles an hour for 2 hours, and I multiply those, I'm going to get 120. Man, that is awful. I'm sure I'll hear about that in class, no doubt. All right, anyway, I think this one can be complicated if you don't transfer 60 minutes to an hour. We've seen that a lot. Be on the lookout for that. I think they might throw that at you in trying to trick you, but I guess we'll find out here in a few days. So I got excited when I saw this because I saw it was a distance time graph, and I was about to say, sweet, the circle car A is faster. But then they asked me, how much faster? And I was like, oh my goodness, how in the world am I going to figure that out? But then I saw, here they are again, 60 minutes. This is 1 hour. Car A went, this would be 80, 90 miles an hour. Car B went here, which is between 60 and 80, which would be 70. Car A went 90 miles an hour. Car B went 70 miles an hour. And it says, how much faster is this? Well, 90 minus 70 is 20. Again, I thought it was comparing speeds, and it is, but they're actually asking me how fast is each car going. We got lucky because they put it in, like this one is 70 and 60, or sorry, 70 and 60 and 90 and 60, which is 1 hour. So I don't have to do any DST triangles with that because it just tells me how fast they were going. I'm hoping we have some that are this easy. What graph illustrates a train sitting at the station waiting to depart? Waiting to depart means waiting to leave. The depart word could throw somebody off if you don't know what that means. So I look at this, I see these motions here. This train is going at a constant speed. It is not waiting, so this is not the answer. This graph is at rest. It's going to have to be a really good answer if it's not this. Then I look down here at this, and I'm like, I have no idea what that is. So I'm going to stick with my original answer and go with B. Again, almost too easy, and sometimes you kind of second guess yourself. Don't. Some of them can be that easy. I'm glad this is on paper, but I don't like the way that this shows up online because the question's here and then the answers are on a separate page. Juan goes for a run. After running 20 minutes, he takes a 5-minute break, meaning that he's going to be at rest after 20 minutes. I have to find a graph that looks like that. So when I go to the next page, does this guy ever stop? Like, I don't see any. That one to me looks like constant speed. So this is not the answer. This person runs for 20 minutes and takes a 5-minute break. 20 minutes, 5-minute break. I'm kind of liking this one. Keep on looking though, because you never know. This person, or this graph at least, I think, is they run for 20 minutes, but then they take a 5-10 minute break. And then this one is they run for 20 minutes and take a 5, 10, 15, 20 minute break. So again, all I'm looking for is the run 20, take a 5-minute break. I'm going to circle B as my answer, and I'm going to move on. I remember seeing this one down here. I need to find a graph of a ball rolling at 2 feet per minute. So I look at A. This is a distance time graph. In 1 minute, it rolled 1 feet. Does that fit our what the question is asking? No, it did not roll 2 feet in a minute. It rolled 1, so it cannot be A. B rolled a little over 1 foot, but still not 2. So can that be the answer? No. This ball, 2 feet in 1 minute, 4 feet in 2 minutes. This one looks like every time it rolls a minute, it goes 2 more feet because 2, 4, 6, 8, 10. I like C. Is there a D to this one? There is. This one rolled 3, so that can't be the answer. Like, share, and subscribe. Peace out.